Haha, just kidding. Mr. Moran here, lesson 58. You're watching this because either you missed class or you were wanted to watch this lesson again. Sorry, so take a moment, read the do now. See if you can figure it out on your own. Otherwise, we're going to actually do it. All right? So, spoiler, here we go. It says factor each monomial. Remember that means to write in expanded form. Kind of talked about it last lesson. That requires us doing the prime factorization of the number. And then writing the other form, the variable part, as all the multiplication. Okay, there you go. That is each of those monomials factored. And we expanded it. We showed all the multiplication. So what are some factors the two monomials have in common? Which I told you I wasn't going to ask you, but I just wanted to see it, So what do they have in common? So people throw out ideas. Well, they have 3 in common. I'm like, yes. They have 15. They have 5 in common. Totally. They have E in common. They have EE in common. They have F in common, or just an F in common. They have a G in common, right? So there you go. They have a ton in common, right? They have all of these, plus maybe they have EF in common. Oh my God. They have GF in common. They have EGF in common. They have so many things in common, right? We could probably list them all. It would take a while, but we don't want to list all their common factors, right? We've been focusing on finding the greatest common factor. So let's try to find the GCF here. We already stretched it out. We talked about it. You did it yesterday. So how do we find the GCF? Well, up here we circling they both have. So they definitely both have a 3, and they have a 5, and they have E's in common. They have 2 F's in common and 1 G in common. So the GCF is 3 times 5 times E times F times G. Now, if we want to make that as simple as possible, we get 15 e to the second, f to the second, g. There we go. Of all the factors they have in common, 15e squared f squared g is the greatest common factor. So, here we go. Inside your notebooks, okay? We're going to continue our understanding of factoring and focus on finding the GCF, along with, some other stuff. Let me see. I think we have 2 parts. Yes, we do have 2 parts. Okay. So for those that weren't able to practice enough, forget it. Let's practice finding the GCF of these 2. And maybe we can look for like a shortcut, right? Shortcuts are great in math, especially if they work every time. All right, so what is our GCF? Again, the table really helps us. We have a 2xz. So our GCF is 2xz. 2 times x times z. Is there a way to find the GCF without having to make the table? It's okay, go with the table every time, but what about if we could make it without the table? Do you have a strategy? Well, students say yes. The students that do say, hey, 4 and 14, the GCF part is 2. The coefficients only have 2 in common. Now, this has x squared, this has x, so they have an x in common. This has z to the first, this has z to the second, so this has z. So yeah, we can kind of almost maybe shortcut it by thinking about all the factors without having to stretch it out. But again, you don't have to. But let's give this a try, right? So we have 24xy and 7x. So, well, just think, 24 and 7, what's the GCF? Well, actually, if you span it out, they only have the number 1 in common. 7 and 24, the only common factor is 1. How about the variable parts? Well, this has xy, this has x, so they only have 1x in common, right? And x, so there's your GCF, x or 1x. Boom, right? And we're going to need this shortcut strategy as we get a little bit more advanced. So I want you to get some more practice. It would have been for homework. That's classwork 1. We must have ran out of time in class. But let's go to 7.2 part 2, right? I think if we're taking notes, right, you can always check your answers. So in your notebook, give yourself the heading 7.2 Factoring and GCF Part 2. Okay. Excuse me. So, I'm talking about factors. So again, just remind us, what is a factor of 50? Not trying to prime factorization, but what is a factor of 50? Throw it out there. 5. Yes, 5 is a factor of 50. How do you know 5 is a factor of 50? Because 5 times some other factor equals 50, right? Who's got another factor of 50? Well, how about 25? Yes, 25 is a factor because 25 times its pair also equals 50, right? Stating the fact that a factor of something is a fact, that factor times another factor equals 50. Okay. So we started thinking of like factors of monomials, right? Same idea. What times what equals this, right? And we thought we can think of a lot, right? We saw this. 5 is a factor because 5 times something will get us 50 e to the third f squared g to the fifth, right? We did that. That'd be 10 e to the third f to the second g to the fifth. This times this equals this. So 5 is a factor. Okay. And you could stretch it out and see all the prime factors of both. Cool. So that's what we've already done. Now, our challenge is, dun dun dun, how do we figure out a factor of a binomial? I want you to pause and think about that a little bit more. What is a factor of binomial? And in the end, it's the same thing. In this case, we're like thinking of what times its pair could equal 25a squared b plus 30ab. So something times something equals this. Right? And that's basically what we've been pushing with the idea of a factor. What times what equals that? And then what happens is someone says, well, Mr. Moran, 1 is a factor. And that would be great. That is a great start. 1 times 25a squared b plus 38b equals that. Yes. But how about something other than 1 or itself? Can you think of something else times something else that would get us our answer? And here's where people start stretching their thinking. And as some students throws out 5. If 5 is a factor, and maybe I would even throw it out, times something else would get us 25a squared b plus 30ab, then 5 is a factor. Could we figure out 5 times something that equals what we started with? And students start thinking, right? Students start saying like, well, 5 times what would get us at least the first part? Oh yeah, 5 times something will get us this, right? It'd be 5a squared b. But that's not our answer. Now we have plus 38b. Oh, plus 5 times what would get us 38b? Well, that would be 6ab. Oh, so we're starting to think about it, right? All right, pause there. I'm going to have to make another video because I got a phone call I have to take. So we'll continue this in the next video.